Okay, all, we are going to now start our 8.9 notes. In 8.9, this will now be out of graphing. I'm sure everyone is relieved, and into solving rational equations. So to solve rational equations, the primary method that we are going to be using is multiplying each side of the equation by a least common denominator so that we can get rid of the rational expression in the denominator and simply have an x to solve for in the numerator that we can use algebra rules that we have already learned. So we are going to just jump right into a few examples of how this will end up working. So example number 1. If we have 7 over the quantity x minus 6 is equal to 4 over x, if we see this side is missing x minus 6, and this side is missing x, what you will end up with is a 7x over x times the quantity x minus 6 all over 4 times the quantity x minus 6 all over that same common denominator of x minus 6. Now if we multiply both sides by that least common denominator, x minus 6 all over 1, and if we do it to that side, multipo says that we must do it to the other side, then what you'll notice is that this will cancel out, this will cancel out, and you are left with 7x is equal to 4 times the quantity x minus 6. From here, you should be able to distribute and solve for x. So we get 7x is equal to 4x minus 24. If we subtract a 4x from both sides, we get 3x is equal to a negative 24. To divide by 3, we get x is equal to negative 8. So what you ended up doing, right, was what we had been doing in 8.1 and 8.2, where you find a least common denominator. Once you do that, you are able to multiply each side by that least common denominator, and that will end up canceling out the denominator entirely on both sides of your equation. So the concept is pretty easy, but it can get a little bit complicated depending on the order of operations of the rational function that you're given. So let's go ahead and do another one. If we have 3 all over a minus 8 is equal to a 7 all over 2a plus 1, you can multiply this side by an a minus 8 over an a minus 8, and this side by a 2a plus 1 over 2a plus 1. And we get 3 times the quantity 2a plus 1 all over the common denominator, 2a plus 1, a minus 8. It's equal to 7 times the quantity a minus 8 all over 2a plus 1, a minus 8. So we can now multiply both sides by the common denominator. And that will end up canceling them both out. And we're left with a very nice simplified expression. If we distribute these terms, then we get a 6a plus 3 is equal to a 7a minus 56. Go ahead and bring my variables to this side and my constants to the other side. And solve for a. Okay, there's a chance that I could make this more complicated, and you know me, I certainly will if the opportunity arises. So for example, if we have m plus 3 all over 3 is equal to 8 over m minus 2, I have to find my common denominator, which that is not any more difficult than it has been. But now you'll see that on top we get a quantity m minus 2 times the quantity m plus 3. And that is what is probably going to irk some of you. So if we now multiply by our least common denominator of m minus 2 quantity times 3 on both sides, it will end up canceling out. I'm going to do it on this side, but I ran out of room. You're left with the quantity m minus 2 times the quantity m plus 3 is equal to 24. And you bet your bottom dollar that this is now a quadratic equation problem. So if we distribute all these terms in, it looks like we will get an m squared minus 2m plus 3m, so plus m, minus 6 equals 24. We have to bring that to this side, so we get an m squared plus m minus 30 equals 24, or sorry, equals 0. That's why I brought it over there. And we now need to factor this and solve. So looks like I can factor this. I'm looking for factors of negative 30 that will add up to be 1. So maybe an m minus 6 and an m plus 6 and an m minus 5 equals 0. If I set them both equal to 0, I should be able to find that I have two solutions, m minus 6 and an m plus 5. Let's do another example. If we have 2x minus 3 all over 2, and that is equal to a 3 over x plus 4, multiply this side by 2 over 2, and I'll multiply this side by x plus 4 over x plus 4. And I get x plus 4, 2x minus 3 all over x plus 4 times 2 is equal to 6 all over that same common denominator, which I will then multiply. I'm just going to say least common denominator, knowing that I'm going to cancel those out. So we end up with an x plus 4 times 2x minus 3 is equal to 6. Now if I distribute this, I end up with a 2x squared plus 6x minus 3x, so plus 3x. Let's just, oh wait, plus 8x minus 3x, so plus 5x minus 12 equals 6. And I get 2x squared plus 5x minus 18 equals 0. So I'm going to go ahead and try to factor this one to solve. And it looks like I could use a 2x plus 9 and a 2x, or in a 1x minus 2. So I get a negative 18 for my constant. I get a plus 9 minus 4 for the middle term, which gives me a 5x. So if I set both of these equal to 0, I can solve for this equation. And it looks like I get an x equals negative 9 halves for one, and an x equals a positive 2 for the other. Okay. Another thing that I could do is make it so there are multiple terms within a single problem. So if I have, for example, a 4/3 minus 7 over n is equal to a 1/6, you have to stop for a moment and think how to get all three of these to have a common denominator. So if I look at the first term, it looks like if I multiply this by a 2n over 2n, I'll end up with 6n, which means I need to multiply this term by a 6 over 6 to end up with 6n, and I need to multiply this term by an n over n, and hopefully now they will all end up with a common denominator of 6n. So if I do that, I'm going to get 8n over 6n minus 42 over 6n is equal to n over 6n. Now if I multiply this by 6n over 1, the common denominator, and I multiply all of these terms by 6n over 1, then they would all cancel out, and I am left with an 8n minus 42 equals n, or a 7n equals 42. If I solve that for n, I get that n equals 6. So remember, according to order of operations, if you have different rational expressions, you need them to all have a common denominator before you are allowed to combine all the terms. So let's do a slightly more complicated example of that. If I have p over p minus 2 plus 2 is equal to 8 over a p squared minus 4. So for this one, what's helpful is to factor and simplify anything that you can to see what is missing from the rest of the denominators. So if you factor that, you'll end up with a p over p minus 2 plus a 2 over 1, and then you get an 8 over, this is a difference of perfect squares problem, so you get a p plus 2 and a p minus 2. Now just like how we were doing in 8.1 and 8.2, this now is a lot easier to see what the rest of the denominators are missing. This one is missing all, so this one will have to be multiplied by the p plus 2, p minus 2 over p plus 2, p minus 2. This one is just missing a p plus 2 over p plus 2. So if you multiply what that's missing to each term and get a common denominator, you'll end up with p times the quantity p plus 2 all over p plus 2, p minus 2, plus 2, p plus 2, p minus 2, all over your common denominator is equal to 8 times the common denominator. If you multiply everything by that common denominator, then you'll get that it'll cancel out for these terms and these terms, and you are left with p times the quantity p plus 2 is equal to 2, oops, it's not equal to, plus 2 times the quantity p plus 2, p minus 2 is equal to 8. So I'm going to go ahead and distribute all of these in, distributing these terms to everything. And you get p squared plus 2p plus, this is your p squared minus 4. So this ends up with 2p squared minus 8, or sorry, minus, yes, 8 is equal to 8. I'm going to combine like terms and move this 8 over to this side. this like term and this like term, so I end up with a 3p squared plus 2p minus 16 equals 0. You can use the quadratic formula or factoring or completing the square to solve any of these. I'm going to try to factor first. So 3p and p are my only factors of the 3p squared. And now I'm looking for factors of negative 16 that will add up to be a positive 2p, keeping in mind that there's a 3 multiplied here. So maybe I'll try negative 2 and a positive 8. So 3p times negative 2 is negative 6, and then plus the 8p gives me my positive 2p in the middle that I'm looking for. So I can now set this equal to 0 and this factor equal to 0. And I get an answer of negative 8/3 for 1p and a positive 2 for my other. Now, one thing that we should definitely make sure when we have quadratic formula is, or sorry, not when we have quadratic formula, but when we have rational expressions, is realizing that we had gotten rid of denominators, but our original problem up here, actually let's do it in a different color. This up here has denominators, and what we know about denominators is that they cannot equal 0. So, you guessed it, we're going to need to check our solutions to see if any are extraneous. So, if you plug in a positive 2, to this guy, or even to this guy, you will get 2 minus 2, which is 0, or a 2 squared, which is 4, minus 4, which is 0, which means that this is an extraneous solution. This one becomes our only real solution. So please double check back into your original equation. For the ones previous to this, we didn't have any terms to add or subtract on bottom, so unless n equaled to 0, there was no way for our denominator to be 0. But when you start getting to factorable and more complicated terms in the denominator, you're going to want to check for solutions that can't exist. Let's keep going under the same theme. So if we have 13 over 3w minus 3 minus 1 over w minus 1 is equal to a w over 9. I'm going to first factor this, and I get 13 over 3w minus 1 minus 1 over w minus 1 is equal to w over 9. So it looks like to get them all to have a common denominator, I need to multiply this one by w minus 1 over w minus 1, this one by 9 over 9, and this one by 3 over 3. And if you do that, 13 times 3, you get a 39 over 9w minus 1 minus 9 over 9w minus 1 is equal to w times w minus 1 all over 9w minus 1. If I multiply this side by 9 times w minus 1, and I multiply all the terms on this side by a 9w minus 1, they will cancel, and I'm left with a 39 minus 9, which is 30, is equal to a w squared minus w. So I'm going to go ahead and bring that constant term over, and I get 0 is equal to a w squared minus w minus 30. And I'm now looking for factors of 30 that will give me a negative 1. So maybe a w minus 6 and a w, plus 5. If I set both of them equal to 0 and solve, I get w equals 6 and a w equals negative 5. Because I have these expressions in my denominator, I'm going to need to check to make sure I have no extraneous solutions. So if I plug in the 6, let's check our solutions. If I plug in w equals 6 to my 13 over 3 times w minus 3, I get 13 over 18 minus 3, or 13 over 15, which is a okay solution. Now if I check in the other one, the w minus 1, I get 1 over 6 minus 1, which equals 1 over 5. That one's okay. Let's check our w is equal to negative 5 solution. We have 13 over 3 times negative 5 minus 3. We get 13 over negative 15 minus 3, or 13 over negative 18. That is a real number. And in our other one, we get 1 over negative 5 minus 1, which equals negative 1/6, also a real number. Both of these solutions are valid, so you're allowed to box them up. What happens if we have an x plus 6 over x plus 3 is equal to 2 minus 5x plus 12 over x plus 3? This one's quite nice because my two rational expressions already have a common denominator, so I just need to multiply this one by an x plus 3 over an x plus 3 to get its common denominator. So I end up with x plus 6 over x plus 3 is equal to 2 times the quantity x plus 3 all over x plus 3 minus 5x plus 12 over x plus 3. If I multiply both sides by an x plus 3 over 1, they will cancel out, and I end up with x plus 6 is equal to 2x plus 6 minus 5x plus 12. And I'm going to go ahead and combine all my like terms. So I get x plus 6 equals negative 3x plus 18. Add 3x. Subtract 6, and I get 4x equals 12, or x equals, oh, this was a plus 3x. Did I? I didn't distribute this negative here. Shame on me. This negative has to distribute to this 5x and to this 12. So this is a negative 5x minus 12. So I get plus 4x is equal to 2x plus 6, negative 3x, and then if this becomes a negative 6 when I combine like terms. There we go. So now if I subtract my 6 from both sides, I get negative 12, or x equals negative 3. Okay, because I have these expressions, I need to go ahead and check. You can see kind of off the bat that if I'm plugging in my x minus 3, I get x plus 6 over x plus 3. If I plug that in, I get a negative 3 plus 6 over a negative 3 plus 3, which equals 3 over 0. This cannot happen, so we end up with no solution for this problem. Okay, let's do one more example. If I have 3c minus 2 over c squared minus 4c is equal to a c over c minus 4 minus 1. If I factor, I end up with a 3c minus 2 over a c minus 4 is equal to a c over c minus 4 minus 1. So it looks like this one is missing c over c, and this one is missing everything. C times c minus 4 over c times c minus 4. So I end up with 3c minus 2 all over c times c minus 4 is equal to c squared over c times c minus 4 minus c times c minus 4 all over c minus 4. Multiply by my least common denominator, and they will cancel out. And I am left with 3c minus 2 is equal to c squared minus c squared plus, make sure you distribute this negative, 4c. Combining like terms, these will cancel out, and I'm left with a 3c minus 2 equals 4c. I can just bring this over here. I get negative 2 equals c. So let's go ahead and check this solution. If I'm plugging in a negative 2, I get 3 times negative 2 minus 2 over, I'm plugging it into this, negative 2 minus 4 times negative 2, so that equals negative 6 minus 2 all over negative 2 plus 8. So I get a negative 8 over 6, which is a real number. And if I plug it into this one, I get negative 2 over negative 2 minus 4, which is equal to a negative 2 over negative 6. And that's also a real number. So this is a valid solution. So this is what you're going to want to do for homework 8.9. Please make sure that if you have some type of rational expression, you are always double checking that your answer is not going to get you an expression that's going to be divided by 0. So make sure you plug your solutions in to double check that you have gotten those. With that being said, good luck.